Hello, my name is Stephen Foster. I'm with C.H. Murphy Clark-Ullman, and I'm here with R.J. Wallace. He's the superintendent of our ASME Code Shop, and we wanted to talk to you about our Eagle Pro bolting product that we're using on a current project here in the shop. Before I go into that, just want to remind you we're based out of Portland. We have branch offices in Tacoma, Washington, and Salt Lake City, Utah. We're an ASME Code Fabrication Shop with specializations in designing and fabricating shell and tube heat exchangers and pressure vessels. We also have field services, which include our Boilermaker services, our Millwright services, and our Refractory specialists. So if you have any need or have a project that we can help you with in any of those areas, please don't hesitate to give us a call.
All right.
So we're here today to talk about a project that we have in the shop that we're currently using the Eagle Pro bolting product with. First of all, tell us a little bit about the project.
Well, it's a 20-inch heater, about 16 foot long, got an operating PSI 1400 on the tube side. Shell side's relatively low pressure. It's only in the 300 pound class rating area. Channel covers are about 3 inches thick. They got 20-inch blind flanges on there that are 1500 pound class.
So we're needing these are larger than what we typically see for a heater this size or a shell and tube heat exchanger. These are 2-inch bolts, is that right?
Yep, 2-inch bolts, 3 1/8 head, and nuts.
So we don't attempt to torque these by hand. We do bring in a hydraulic torque wrench.
Right. Yeah, we end up going around with hydraulic torque wrenches because most torque processes you go up to about 1,000 psi by hand, and then up above there, just more efficient to go with the hydraulic.
Have you used the Eagle Pro?
Yes, we
product
have used
before?
a version of it, probably about 6-7 years ago,
Okay.
and that one was a little bit older style, a lot more bulky, a
Okay.
little more cumbersome.
Well,
This
this
one that
one-
we had is a lot more compact, seemed to be a little more efficient, a lot easier to handle.
So this is similar to the one that we used. This is a model EHW4, but we used a TX4. Very similar to this. What do you like about this design?
Oh, it's nice and compact. You can get it, in tight places. If you got nozzles in the way or another flange in the way, it's easy to get in there. Whereas some of the older ones were a lot more bulky and had a big foot coming off of them. Just, pain in the butt.
Hard to get
use.
in on the nut.
Yep.
So, and this is
That's the hydro pump that runs it. So you just set whatever pressure that correlates with your whatever torque you want to go. So like we were hitting 3,000 for max torque, which was like 7,600 psi on that. So
interesting.
quite a bit. It's up on the upper end of that one.
Let's take a picture or take a look at the picture here of it actually in operation. What is the numbering on the bolts?
That's a pattern we use to keep jumping back and forth so we don't torque one side down and cause the flange to get into a pinch. And usually when that happens, you won't ever get the one side to seal because it's obviously pinched and not getting any pressure on the gasket.
So you can't just do a round robin. You've got to do a pattern, a star pattern of some kind to make sure that it's has a consistent pressure on the seal.
Yep, exactly.
I understand. Okay, so we're going to go ahead and take a look at some footage of the hydraulic torque wrench in actual use. I think here we're actually seeing them put the wrench on the bolt. It's really seems really simple. I mean, it doesn't seem that hard. I mean, how does he know how far to go when he's torquing that down? Does he go to a certain pressure and stop?
No, we set the pressure on the machine so it can only go to so much. So
Okay.
if I want it to go to 7,600, it goes to 7,600 and it stops.
Okay.
And it won't go anymore. And then you let off the button and it will release itself and move on to the next bolt.
Now, do you do it in increments on the torque
Yes.
poundage?
Yeah, we generally try to go like thirds
Okay.
of what final destination is going to be.
So you do that pattern, 1/3 of the torque you want, then you do the pattern again, another third, like this?
Yep.
Okay.
Yep.
And so at the very final one, do you go over a little bit, or do you try to hit it right on the nose?
No, we try to hit it right on the nose. And we go around and make sure that, sometimes we'll hit the final one twice just to make sure. we don't
Okay.
miss any.
Okay. And now, how much faster is this compared to using it manually?
Oh.
Using a manual torque wrench?
It's a lot faster. I mean, those guys would be exhausted after the first one.
It's very physical, demanding.
Yeah, yeah, 'cause basically you're gonna be taking a hand torque wrench and a multiplier and you might have to multiply it by 3 times to get
Mm-hmm.
up there with a 1,000-pound torque wrench.
Okay. Well, I think that pretty much covers this topic for this video. We really appreciate you watching it. If you have any project we can help you with, please don't hesitate to give us a call. My name is Stephen Foster. This is RJ Wallace, and we wish you a good day. Thank you.